one India present here. Here we will see about a short survey on optical networks. Actually, in this presentation, let us see about the revolution in the network, optical networks, WDM, and what are the switching mechanisms used in the optical communications and OPS, and future enhancements in the optical communication. The first one is the revolution in the networking. Actually, in the information technology era, there are relentless needs for the networks with extremely high capacity. Actually, here, day by day, not day by day, the hour by hour, there are use of network users are increasing. So, there is the need of high capacity networks. At this juncture, to make the dreams of the network users come true, tremendous result has resulted by using the optical technology. This is the great boon to the world of communication. So, we all know that the telephone is invented in the 18th century by Alexander Graham Bell. That time we were using the circuit switching. That is a internet connection between the transmitter and the receiver. At that time the optical communication has no significant effects, because at that time also the optical is used as the normal circuit switching. So, in the 1980, we were using the electrical transmission for transmitting the data. Not data, transmitting the information. In the mid-1990s only, the optical networks were used. That time, the telephone networks were merged with the IP network. That time, that is the concept of packet switching were arise. That time, we use the optical communication networking. The use of optical fiber for the communication is the first step of optical networking. When copper line is used as a channel, bandwidth is limited because of electronic processing. Optical networks are high processing, high speed, high capacity telecommunication networks with using the optical technologies. Light is, that is lambda is equal to C by F. Here we are using the C is the speed of the light, that is 3 into 10 power 8 meter per second, and we are using the high frequency signal. So automatically the wavelength will be small. So we are using the concept of WDM, wavelength division multiplexing, by using the wavelengthing concept. So the light has higher frequencies and shorter wavelength. Greater number of information bits can be transmitted in optical networks. Here the optical networks operate at a rate of terabits per second. Hence it is having a higher bandwidth. Actually, nowadays we are using the optical networks because of high bandwidth, and it is a speed of 50 terabits per second, and it is using the WDM concept, that is wavelength division multiplexing. The wavelength, in a wavelength, more number of channels are merged and it is transmitted. And here it is having the low signal attenuation, and distortion is less, and power consumption is less, and moreover the space requirement for optical network is small space requirement. And WDM. Actually, WDM is nothing but wavelength division multiplexing. In the normal communication systems, we were using the concept of TDM and FDM, that is time division multiplexing and frequency division multiplexing. In the optical communications, we are using the concept of lambda. So here, we use the concept of WDM, that is wavelength division multiplexing. This WDM allows many channels on a single fiber without the need of high-speed optoelectronic devices to the end users. That is the concept of WDM. Actually, in the 1970s, this WDM techniques were under the scanner of the research, but in the mid of 1990s, this WDM were used, because that time we were using the concept of packet switching, that is telephone networks is merged with the concept of IP network. That time packet switching concept is required, that is we use the concept of WDM. And the advantages of WDM are increased usable bandwidth and reduced processing cost and protocol transparency, because we were using the protocols in the packet switching. There is a protocol transparency and efficient fault handling. Okay. Actually, the boon of the world communication is, we thought that there is the optical communication. In the optical communications, we are using the optical technology. This optical networks, in the optical networks, we are using the concept of WDM. So this is the basic concepts of optical networks. Here, we will see about some switching mechanisms in optical networks. There are three types of switching concepts. One is OCS, and another one is OBS, and another one is OPS. OCS is nothing but wavelength router switch. The expansion of this OCS is optical circuit switching. This is like normal circuit switching. There should be one intended transmitter and receiver. There is a dedicated path between the transmitter and receiver. So here the wavelength usage is minimal wavelength usage. This is like a normal switching concept. But the advantage of this method is there is no loss in the OCS. In the concept of optical bus switching, we will see the optical bus switching and optical packet switch in the next slides. Actually, the optical bus switch, there is it is characterized by the incoming packet. The incoming data is characterized by two parts. One is header and another one is payload. The header is electronically processed, and this header will process first. The header will first going from the node to the intermediate node. That is sended from the intermediate node, and it searches whether the intermediate node is available or not. So it will check. That is, this is the concept of resource reservation mechanism. One-way resource reservation mechanism. First, the control packet will move from the node that is sender to the intermediate node, and it processes and it checks whether the intermediate node is available or not. If the intermediate node is free, again it will intimate the sender to transmit the packets, and this data will be, that is already we are processed the header as well as payload node. This payload will be transmitted from the node to the intermediate node or sender to the intermediate node in the form of burst. So that it is called as optical burst switching. Actually here the incoming packet is first, the incoming packet is coming, or the sender will initiate the transmission. That time the entire packet will be characterized by two parts. One is header and another one is payload. The payload will be as it is in the optical domain, and it will be available in the sender, and the header will be processed in the electrical domain, and it will be transmitted to the intermediate node. This is for the purpose of resource reservation mechanisms. So it will check and then find out whether the intermediate node is free. If it is free, and it will inform to the sender, and the sender will transmit the optical payload in the form of burst. That's why it is called as optical burst switching. So this is the diagrammatical representation of optical burst switching. Here the optical control packet will be transmitted first, and after finding whether the intermediate node is available, and then it will transmit the details to the sender, and then it will transmit the packet next. The next one is optical packet switching. In the case of optical packet switching, again we are having the concept of there is no concept of splitting the payload and header. First what happened is optical packet, it is transmitted like a normal packets. After coming the packets, the packet header is processed in the electronic domain, and the header will be in the as it is in the optical domain. This is the architecture used in the optical packet switching. Actually here what happened is, if the incoming packet is coming, then the optical packet is processed like, it will be again characterized by two parts. One is optical header as well as payload. The payload will be delayed by using the optical delay lines, and the header will be processed in the control module, and it finds out to which output it will be transmitted, and then it will find out at which output it will be transmitted and whether the port is available or not. So up to the end of the port available, the optical payload will be stored in the delay lines. So after finding the output is free, this control module will be again processed from electrical to optical domain, and it will be merged here, and this packet will be transmitted. This is the architecture. This will be designed by the Harald Overbein. So these three are the concepts of switching techniques used in the optical networks. One is wavelength router switch, that is called as OCS, optical circuit switching, and another one is optical burst switch, and another one is optical packet switch. Nowadays, the research is going on in the field of optical burst switch and optical packet switching, because this wavelength router switch, connections between the sender and the receiver. So there is a dedicated path, but the concept is there is no loss, but it is like an ordinary cable. So that time we are not using the WDM or the remaining concepts. The functions of the packet switching is routing. The functions of packet switching is routing, forwarding, and then switching, and then buffering. So the four concepts are used in the optical packet switching. Here the switching techniques used in the optical is OCS, OBS, and OPS, and routing techniques we are using is FDL, wavelength conversion, and deflection routing. FDL is fiber delay lines. Already we have seen in the architecture, that is the optical payload is stored in the delay line, and at the same time the header is processed in the electrical domain and it is processed. So here for storing the optical packets we don't have an optical buffer. So what we do is the optical signal will be stored by using the delay lines. We are sending the optical signals in some lines, delay lines. It will make the signals to be delayed. That is fiber. That is FDL. That is here offer only fixed and finite amount of delay, because already we have 10 rounds, means the optical signal will be propagated in the 10 rounds and it takes some delay amount of time, and it will increase the delay. Suppose I don't want the delay that time, even though we don't need the delay, but the optical delay line is 10 rounds, means again the signal will be processed in 10 rounds, and then after that particular time only we will get the signal. And it may cause the packet reordering, because in the packet switching all the packets will be transmitted at the its own order and the received in the own order, and it will be again accumulated together. But here because of this delay, this will cause the packet reordering. And another one concept is wavelength conversion. Here if suppose the incoming packet is don't have the wavelength of that particular port, again the available port wavelength can be converted. That is wavelength conversion method. First one is fiber delay line. In the fiber delay line, the signal will be processed in the delay line so that it gets delayed amount. The second one is wavelength conversion. If suppose the packet is coming to the particular port, the port is not having that particular wavelength available, then it will convert the incoming wavelength to the another wavelength. That is routing techniques 2. That is wavelength conversion. And another one is it avoids packet reordering, because whenever the packet comes, it will convert the packet into another wavelength and then it will immediately transmit the packet, so it will avoid the packet reordering. And another one is deflection routing. In the deflection routing, it does not require hardware upgradation in the OBS nodes. The packets may arrive out of order, and it is having the less efficient than buffering and wavelength conversion. Because in the case of buffering, the optical packet will be stored in somewhere. Either it can be converted to optical to electrical, and then it will be stored in the buffer. But in the case of wavelength conversion, again it will convert from one wavelength to another wavelength. But this is not the case of deflection routing. So in the optical OPS, that is optical packet switching, there are OPS networks can be categorized into two parts. One is slanted networks and another one is unslanted network. That is in the case of slanted networks, the packets are of fixed size. So if suppose we are transmitting 1024 bits packets, means in the entire network we are transmitting the same size of packets, and it is placed in time slots. The entire time slots of the particular port will be divided into number of time slots. At the particular time slots only we will transmit the packets. Even though there is no packets in the time slots, the slots cannot be optimally utilized. That is the concept of slanted networks. And another one is unslanted networks. Any packets can arrive at any time, and packets may be of different size. That is the concept of unslanted networks. So in OPS we are having routing technique is wavelength conversion, FDL, and deflection routing. And in the case of networks, we can categorize into two types. One is slanted networks and another one is unslanted networks. And here we can use, already we have seen the architecture. No, in this architecture either we can place the buffer in the input side as well as in the node side as well as in the switch. So we can use the buffer. In this buffer, the optical signal will be converted to electrical and then it will be stored there. There is no full optical switch we are having. So here we can use class-based model or port-based model. In the case of class-based model, each node transmits the packets according to their classes. We can place the buffers based on their class. But in the case of port, we can use only the port model, that architecture. Actually in this, suppose we are placing the port here, suppose if this is a port based model, then for a particular port, this is the output port 1 means in this particular port we can use the buffer, that is a port based model. If suppose we are using the concept of class based model, here the incoming packets will be divided into more number of classes, service class 1, service class 2, service class 3, like that we can split and we can allot different wavelengths for each and every class. And then for class based model, we can place buffer for the particular class. That is for service class 1 means we can use one particular buffer. For the service class 2 buffer means it will store only the service class 2 packets. So we can assign the wavelengths for that classes, class 1, class 2, service class 1, 2, 3 and whatever required we can use that particular class. So up to now what we have seen about what is optical technology and what is optical networks. In this optical networks, what are the types of switching used and what are the size of routing concepts used in the networks. And another one is QoS. That is a very important concept in the networking, that is a quality of service. The quality of service refers to the capability of the network to provide better service to the selected network. This quality of service is having two types. One is QoS experienced by the end user and QoS that is from the point from the service provider point. That is quality of services from the end user side and quality of service from the network side. That is the two types of QoS. Actually here we can improve the QoS because day by day there are network users are increasing, so we can optimally utilize the available bandwidth as well as we can optimally utilize the available networking concepts. So we can improve the QoS, that is quality of service can be improved. It can be improved in two methods. One is by using parametric methods and another one is by using architecture methods. In the case of parametric methods, we can take the what are the parameters available that affect the quality of service in the packet switching. That is packet loss rate, bit error rate, delay, reliability, bandwidth, latency, jitter, availability, recovery time, response time and so on. So we can take each and every parameters and from the parameters we can improve the quality of service parameters. Otherwise we can go for the architectural issues. So we can take the, we can modify the available architectures which is used in the OPS and OBS and then we can modify that. So the research topics in the optical network is, in the present scenario 128 to 160 wavelengths are used as the operating wavelengths of WDM. Actually what is the concept of WDM? In a single channel, in a single wavelength we can transmit more number of channels. In the present days we are using the 128 to 160 wavelength. We can improve by improving the quality of service. And then to increase the operated wavelength, laying on a new fiber is absolutely not necessary because already we are having some networking concepts. So we cannot take up the network and then we can lay down the new optical network is too much costly. So we can increase the parameter by increasing a factor of 16 or 32. That is the wavelength lambda is equal to 16 or 32 in the concept. So we can use the operating wavelength will be improved and improvement in high speed optical memories because we are having only the electrical memory and then we are using the electrical buffer. We are converting that optical into electrical and then we are storing the optical signals. So here we can use the full speed, high speed optical memories we can invent. And actually here we are using the increasing gigabit network architecture will improve the network performance because we are having normal architecture. In this architecture we are introducing more and more speed of the optical networks, so we can improve its architecture by using the gigabit network architecture. So some simulation software used in the optical concept is NS2, Photonic Scan, Omnet Plus, OptiSims, GIST, SWANS and then SSFnet, that is Scalable Simulation Framework. Actually, I think I am giving an overview of optical networks. From this optical networks, you just search what are the network